Hello, hi everyone. So welcome back to my channel and let's start with today's Leetcode challenge, that is rotate string. So we are given two strings s and goal and we have to return true if and only if s can become goal after some number of shifts on s. A shift on s consists of moving the leftmost character of s to the rightmost position. For example, if s equals to a b c d, then it will be b c d e a after one shift. Okay, so we are shifting every character in one shift to its right position. So we are given these example. So s is equals to a b c d e and goal is c d e a b, and it is true because after doing two shifts, if you can see, a comes here, then b comes here, so c d e a b we can get, and that's how we are returning true. So let's just move to the intuition part. Okay, so we can start with the intuition building part. So we have this string, we have to make it like goal. So if you see how many times it is rotated, so it is two times rotated because these two characters are at the last. First brute force approach will be we try every rotation. So how you will rotate it? So you will pick first element and try placing it at the end. Okay, so now you try placing each element every time. So after first rotation, it will be b c d e, then you will place a at the end. Now since it is not equal, so you try doing second rotation. And how many rotations you can do? How many rotations you can do? At most n rotations, where n is the length of string. Why? Because if you see, you have a b c and d. So how many times you can rotate it? You try placing this here, then it will be b c d a, then you place b here, so it will be c d a b. Now c here, so it will be d a b and c. Now you place d here, it will be again a b c d, and you have like original string. So maximum you can do n rotations. After n, you again be repeating same number of rotations, same number of cycle. So for this, what you are trying, you will try at most n rotations, and after every rotation you try equating it with goal if you have got your answer or not. So second rotation, it will be c d e a b, and after second rotation, if you try checking it with goal, you will get your answer. Yes, they are true, that it is a rotated string of your string s, right? So now we know that the brute force approach will be try every rotation, and we know how you try for every rotation. So for small, pseudocode will be we try going for I 0 to n, right? Because we have to try for each character. So now there are two methods that with which you can rotate the string. Either you can use, first is you can use inbuilt method, right? Or you can create string manually. Manually will be like what you are seeing every time, that when you are rotating this string by one character, right? So what you are doing, you try getting first character and you try getting this and you place this at the end. So every time what you can do, you can create another string, let's just say string temporary, that will be your s dot substring, and substring will be from 0, length will be 1, right? This is you can get temporary, and this will be your length will be n minus 1. So again, what you can do, s dot sub str, so you can name it like something else. So you can name it right part, because it will become right, and similarly this will become your left. So right will be 0 to 1, okay, one length starting from 0, and then your this part will be starting from 1, okay, and length will be n minus 1. This is a first index, and length will be n minus 1, because you have to remove this character because it is n minus 1 length, right? Now you join these two, left plus right, and now you can compare it with your goal. So this is one method. Another method would be you can try using this inbuilt method. In C++, we have rotate function with which you can use methods for rotating, right? So these two methods you can use. And rotate method in C++, we have direct rotate method which get here three parameters, right? And these three parameters are, this is starting iterator, okay, and this is ending iterator, and this iterator basically what it is, from where you have to like rotate, how much part you have to rotate. In this you are seeing that you have to rotate only one, so you just have to pass what is the length, one. But since it should be an iterator, so how you will pass it, you will pass it like your begin iterator plus length of rotation. Okay, in our case it is one, but if you know, if you sometimes like rotate it by two times, like AB you have to rotate every time, so then you have to add the length as 2, right? So now you are good with this approach, and let's just calculate the time complexity. Okay, because we have to optimize it. So if you are seeing that we are going for each character here, so it is big of n and this rotate. Okay, this inbuilt function also, and when you try doing manually, it will take n. Okay, big of n time, so it will be somehow equal to big of n cross n, that is big of n square, right? And space complexity, if you try using this method rotate, so you will not be taking any extra space because you will pass the same string here. But when we discuss this manual string update, so what you will do, you try creating another string. Okay, so let's just say we will not use any extra space. You can also like don't use extra space here and do that operation in this original string by manipulating, and you can try it on your own, but the space complexity will come out to be big of 1 only. Okay, so now interview will ask you to optimize on this time complexity, right? He can ask you like optimize this and try if you can do it in this space or not. That is not the constraint, but you have to optimize in this n square to like n log n or big of n, anything. So now we will do the optimized version. Okay, now one thing, we have this string abcde and the goal is cdeab. Okay, so string is abcde and our goal is cdeab, right? Now what you see, this should be like this is a rotation of the string. What we can do, we can do concatenation of same string. Why I'm saying, let's just have a dry run on that and check if that should give our answer or not. So we have this a b c d e, then we again concatenate the same string a b c d e, and it is proved that this string contain all rotations of s. Okay, your original string. Why we are saying this, because if you try rotation, every rotation, so one of the rotation, we will write rotations here. First is a b c d, second is b c d e a, right? Then c d e a b, then d e a b c, right? Then e a b c d, and finally again our original string, that is a b c d e. And now we will check if we have find all the rotations in this original, in this make our big string. Okay, so if you are seeing a b c d, a b c d e, or it is here, yes, we are able to find. Now b c d e, if you are seeing b c d e, yes, we are able to find it, right? So this is first one, this is second one. Now c d e a b, right? So it is also present here. So c d e a b. Now d e a b c, again we are able to find this, right? Now e a b c d, yes, we are able to find it, and this is the same as the first one. So yes, it is also present. So what we are seeing from this, that when you concatenate the same string twice, you are able to find all the rotations in that string. Why? Because if you are seeing this length is already smaller than your this string, right? And then you, since you are adding both of the strings in the same order, then you will surely be able to find that string in your big string. So what you can do, you can create this, okay, concatenated string. Let's just say this is a or anything, right? And you try finding your goal in this string, and if you are able to find this in your string a, then it surely means that it is a rotation. Okay, so now the time complexity thing, because this code will be a very simple, it's just that we have to understand why this concatenation is working, right? How it is working. So we have discussed that it will surely contain all the characters, because if you try removing this, right, so you already have this string originally and you added same string again, so you have that first character at your last, again you are having starting character at your end, that is common. So when you try placing the c to the end, you will surely be able to find it in the next half of the string. Okay, and since you have same characters on its left side, so this will be surely present in your big string. So that is the main reason. Now the time complexity part and space complexity. In the space complexity will be big, since we are creating new string, so that will be big of 2n, because this length was n and this length is 2n. So space complexity directly we are seeing 2n. Now the time complexity. So internally, if we are using any find function in C++, that is big of n, right? So internally, that we have discussed, that this is big of n cross m. So, apologies. So n cross m, where n is the length of this string. So this is our 2n, and m is the string length that we have to find. So in our case, it will be big of 2n star n, right? So it is 2n square. But if you if you try finding it with KMP, right, you have this string, you have this string, and if you try using KMP, then you can surely find it in big of n, right? So that is your point, if you want to use KMP or not. But if you try directly using this find function in C++, that surely takes this much time, right? So we will do the code for these both approaches, and we will move to the coding part now. Okay, so we can start with the coding part. First we try gathering this length of both the strings. So it will be s dot length and m is equals to goal dot length, right? Now first we try doing that substring method that we have discussed in the brute force. So int I is 0, I less than n, I plus plus. So how many rotations? We can do n rotations, we have discussed. So for every rotation, what we have to make, we have to move this character towards right. So now your original string will be, first you add the substring for this part. So it will be starting from 1, length will be n minus 1, right? And your new character that is added, its first character. So it will be s dot sub str starting from 0, length 1. Okay, this is the length and this is the starting pointer. So now this has become your one rotation, and now check if s is equals to your goal. If it is true, then you will just return true, and for every after n rotations, if it is not equal, then you will just simply return false. Okay, now we'll try running it. Okay, so it is passing, so we try submitting it. Okay, so it is submitted successfully. Now we do that approach of rotate method. Okay, so similar thing we'll do. First we will rotate. Okay, in this rotate, but we have to pass the original string first pointer, and then there was another pointer last end pointer, because we have to take, this is the first, this is the last, right? In case you need any rotation between these pointers, you can pass these also. So now the third parameter that is in the middle, we have to pass is the length of the rotation. So we have to pass only one length, so that will be s dot begin plus 1, because we cannot pass 1 directly. And every time we are doing, we will just check if s equals to goal, we will simply return true. So we'll try running it this one also. Okay, so it is also running fine, and yes, it is also working perfectly fine. So now we have done all the brute force. Now we will do the optimized version. Okay, so now we will do the last approach. First we can directly compare if n is not equals to m, that is, they both strings cannot be equal anytime, so we can return false simply. And we can now create our big string, that is a equals to s plus s, and now we can try calling the find function. So a dot find, but we have to find goal, and if it is if it is equals to -1, because this find function can return the first occurrence of this goal, or it returns -1 in the form of non-position. So we can directly compare it with this non-position. If it is equal to non-position, that means it is not found. So, and if it is not equal, that means it is found. So we can return true here, and now we can try running it. Okay, so it is working fine. Now we try submitting it. Okay, so it is running perfectly fine. So thanks everyone for watching. In case you do like this video, please do hit that subscribe button and turn on the notifications. And in case you have any questions or DMs, you can ask me in the comment section or DM me on my Instagram. I've added that in the description. And if you have any alternate approach, do share that in the comments so that everyone can take a look at it. Thanks everyone.